Hi everyone, welcome to the new video. So today we will see some DevOps interview questions which are at advanced level and their answers. So without further ado, let's start our video. So our first question is, how would you perform a zero downtime deployment for a microservice running on Kubernetes? So the best answer is, you should include about the rolling update, about the blue green deployment, upon the canary deployment. So zero downtime deployment means that when the users never experience a failed request while a new version is getting deployed. So about the feature flags, that only the particular feature is getting deployed, not the whole code. About the progressive delivery using Argo rollouts, and then about service mesh, you can tell because service mesh like istio and all of this handles the microservice. You can tell about that too. So include all these keywords to to make your answer more effective. How will you that you will configure after using this common deployment strategy? You'll configure readiness probe, liveness probe, startup probe, set max unavailable 0, max search 1. The deployment sequence begins all pods, then new pod created, readiness probe pass and traffic shifted, and then old pod will get deleted. So real world example is that Netflix doesn't release new version to 100% of users immediately. First it will be releasing to 5%, then 20%, then 50%. So this is like canary deployments. You can tell about this and include real world examples. Now, question number two is, Kubernetes node becomes not ready. What happens? So, the node controller continuously monitors nodes. So, a node, the controllers are the important components of a control plane of a Kubernetes. So, a node controller will continuously monitor node, and when a node becomes not ready, Kubernetes marks the node unhealthy. Scheduler stops assigning new pods. Existing pods remain temporarily. After for temporary time, the existing pods will remain. After the eviction timeout, pods are recreated elsewhere. So the actual behavior depends on, like, you can include pod disruption budget about because of taints, because of toleration and eviction timeout. So while the stateful set behave differently from deployment, database requires persistent volume clean, CSI driver to avoid data loss. So tell about all these things, that why, when node becomes not ready, then what all happens. Okay. Then a real world example is a cloud VM crashes. Kubernetes recreates stateless application automatically. But databases, because the stateful set requires storage reattachment before recovery. Okay. Now explain the GitOps architecture. So Git becomes a single source of truth. Instead of manually deploying, we will have Git repository, which will have GitOps controller. The GitOps tool is Argo CD and Flux CD. So whatever developer will push the code, CI builds Docker image, manifest updated, Git commit, and Argo CD detects the change and it will sync automatically and cluster will be updated. So benefits are audit trails. For auditing, we have trails, we have sequence, rollback, version control, and declarative infrastructure. What happens if etcd crash? So etcd store Kubernetes clusters. It's like a database which will store what pods are available, what pods are deleted, what pods are not healthy. So it contains pods, it contains secret, contains node, config map, deployment, services, everything. So if etcd is unavailable, then API server becomes read only. So no new deployments will happen because we are not having the information now. We are not able to access information. No scheduling, no scaling, running workloads continue. The workloads which are currently will continue, but no new thing will be able to be created because our database is lost. So recovery is restore from snapshot using etcdtl command. Okay. So run. So it's basically like always run 3 node or 5 node high HATCD cluster. Okay, because uh, anytime this thing can happen and it will be a disaster. So explain the cap theorem in DevOps. It's like consistency, availability, and partition tolerance. So therefore, choose consistency plus partition or availability plus partition. Like examples like Zookeeper, consistency, Cassandra, availability. So uh, availability, Kubernetes, etcd, consistency, Redis cluster, availability. You know, these are things we can use to maintain to achieve cape theorem or consistency, availability, and tolerance. Okay, so either we can use consistency plus tolerance or availability plus tolerance. Okay, sorry, consistency plus partition tolerance and availability plus partition tolerance. Now how would you troubleshoot a production outage? So never never start with that you'll restart the services. First, follow structured approach. Like step one will be we'll observe CPU, memory, disk, network, logs, alert. Step two will be determine infrastructure, application, database or network. At what level the error is. And then step three will be check Prometheus, Grafana, whatever your monitoring tool. And then step four will be rollback. So at least we'll have perfect evidence to find the root cause analysis. But yes, we cannot wait for a long time, and rollback has to be done if it cannot be solved within 5 to 10 minutes. So, difference between Docker and Containerd is Docker is a complete container platform, and Containerd is only the runtime which manages, containers which are getting created using Docker image. So, Docker Containerd runs in Linux kernel. So, Kubernetes no longer require Docker; it directly communicates with Containerd or CRIO. Then I explain Kubernetes networking from pod to internet. This is a very, you know common question which is asked. So pod with, so this is a, more deeper level, with pair Linux based CNI plugin, node network service, ingress, load balancer, internet. And popular CNI plugins are Calcico, Cilium, Flannel, Weave. So we need to talk about network policy, ebvf, IP tables, IPVS, overlay networks, and VXLAN. So this is a more deeper level we can explore. If you want to understand this, let me make a very separate video about this, which I'll be telling about how to dissect it in a more deeper level. Then how would you secure a Kubernetes cluster? So security layers like image security, registry security, airbag, network policy, secrets, encryption, pod security, runtime security, audit logging. Use Flacco, Trivi, OPA Gate Keeper, Kyverno, Cosine, Vault, enable least privilege, namespace isolation, secret encryption, image signing, admission controllers. Now, when how will you design a highly available CI/CD pipeline for millions of deployment? So it will be like GitHub, about webhook you'll talk about, then agents you talk about, then Argo CD, and then notifications about distributed build agents, advanced improvement, remote build cache, parallel testing, GitOps, canary deployment, auto rollback, progressive delivery, observability, security scanning, secrets management. So talk about how you are executing the jobs parallelly, how you are managing the agents on which your jobs are running, about what the stage is, about GitOps principle. This all you can talk about. Explain the Kubernetes control plane internal. So the control plane, basically this is kubectl, API server, authentication, authorized admission controller, etcd, scheduler, controller management, manager, then kubelet, then container runtime. So user submit deployment, API server validates request stored inside etcd, scheduler selects node, kubelet receive assignment, container runtime creates pod, and status updated in etc. This is a flow. So yeah, that's all. That's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.